My dear students, in this video, uh, two different operations are discussed. Both are finishing operations. So, finishing operation is normally done at the final stage of any product manufacturing process. After getting the required shape and dimensions, a certain product in certain surfaces we need to finish very well because that is a functional requirement in certain cases. For example, it will reduce the wear resistance. Also, it will enhance the fatigue strength. Also, it will resist the corrosion, and it will also reduce the power loss due to friction. So all these are the functional requirements. So it is a vital, important, important operation in certain case, especially where we need good surface finish. So here are some finishing operations like lapping, buffing, honing, super finishing, etc. So we'll discuss one by one. What is lapping? The lapping is one of the finishing operations widely used. So here, instead of a bonded abrasive tool, oil-based fluid suspension of very small free abrasive grains are used. So that is the major difference between the grinding and lapping. In grinding, we are using an abrasive wheel, but here, instead of using an abrasive wheel, we are using abrasive particles which are suspended in an oil. So it is an oil-based fluid suspension of very small free abrasive grains or particles like aluminum oxide and silicon carbide, with the typical grit size is very small, that is 300 to 600 microns. It's called a lapping compound. This compound is known as lapping compound. It is applied between the workpiece and the lapping tool. So lapping is normally done by using a tool, that is a lapping tool, and in between the lapping tool and the workpiece, this lapping compound is spread over the surface. The lapping tool is called a lap, which is made of soft materials. So the lapping tool is made of soft materials like copper, lead, or wood. The lap has the reverse of the desired shape of the work part. For example, if you want to have a convex contour, if you want to finish a convex contour, you have to use a concave surface on the lap. Lapping is sometimes performed by hand, so it can be done by hand also, but lapping machines are used to get the more accurate and good surface finish. Lapping is regarded as the oldest method because in olden times people used to do finishing the tools or weapons, etc., by this method, by using powder of the abrasive particles, and it is mixed with oil, and it is rubbed over the material which you want to finish. The material removal in lapping is usually very minute, that is around 3 microns to 30 microns, and in some cases it becomes 80 to 100 microns. The cutting mechanism in lapping is that the abrasive becomes embedded in the lap surface. So the cutting mechanism of cutting is also same. Here also shearing takes place, but the only the size is very minute, micron size. That's the difference. Also, concurrent cutting action of the free abrasive particle is there. So because the abrasive particle is also moving in the liquid surface, so concurrently it is one by one, it is the machining operation is taking place. Lapping concurrent means simultaneously different abrasive particles do the cutting action. Lapping is used to produce optical lenses. So this method can be used for making the shape of the optical lenses, and metallic bearing surfaces for finishing the bearing surface, gauges, for manufacturing gauges, which is we should have a perfect surface. So all these cases we need to use lapping. So characteristics of lapping process. It uses a loose abrasive between lap and the workpiece. That is one of the characteristics. Loose abrasives. Usually lap and workpiece are not positively driven but are guided in contact with each other. Relative motion between the lap and the work should change continuously. Relative motion between the lap and the work should be changed continuously. That means it is the speed will change, vary. So for initially we will start with the slow speed, then speed can be increased. The path of the abrasive grains of the lap is also you should change the path, because do not repeat the same path, because that may produce some scratches on the workpiece. To avoid that, it has to means the direction of the rubbing should be changed instantaneously. So this sketch explains the lapping operation. It's a simple one. You can see the workpiece having a convex surface, and this is the lap. The dark portion is the lap, and the lap is having a concave surface. And in between, you can see the lap compound, that is abrasive grains with the oil base. That's all. So this lap has to move over this work surface. So because of the minute abrasive particles in between the lap and the work, that will rub over the surface, and very minute particles will be removed from the surface, so that you will be getting a good smooth fine surface over the workpiece. So this is the lapping tool. You can see the lapping tool. So here in this first sketch, it will explain how the lapping operation is done. So you can see a lot of sharp cut edges on the surface, rough surface. So when it is moved, that means the lap is moved over the workpiece. All these sharp cutting edges will go out, and it becomes a very smooth one. So here you can see a lapping tool. This is the lapping machine, and the top portion is the this is the one which is rotating. It is a circular one, and these are the work pieces which are kept on the bottom piece of the lap machine. And here you can see the guide rail, and all these are the workpiece are arranged on this top surface, and this lap compound is put in between this, and after lowering this the top portion, it is rotated. So the top part will be rotated over this one. So because of the rubbing action, and in between there is a lap compound, you will be getting all these identical small work pieces will the surface will become very smooth after machining. So this is very simple. This can be driven by using a motor, and the speed can be adjusted. And here the same thing, here it is used for finishing the flat surface. Here you can see all are cylindrical parts, identical cylindrical parts. The same thing can be kept over the table or the bottom half of the lap, and after keeping the lap compound here, the upper lap should be lowered, and it will become contact with the surface of the workpiece, and it is rotated. So here also you can finish the cylindrical surface of the workpiece. So when we turn this upper lap, the cylindrical the workpiece also will rotate the same speed, same manner, so that the entire surface will be finished. So what are the different compounds used in the lapping machine for lap? These are the aluminum oxide and silicon carbide. Just like in grinding wheel, we are using the same thing, but the grain size is different. Here it is very small, 5 to 100 microns. Then chromium oxide, this is grain size is 1 to 2 micrometer, and boron carbide grain size 5 to 60 micrometer, and diamond grain size is 0.5 to 5. That is, it is represented by volume, that is in unit volume how many what is the size of the particles. Lubricating materials of the lapping, so any oil can be used, so machine oil, rape oil, it's a vegetable oil, grease, all these are commonly used for lapping. Then the technical parameters affecting lapping process are the pressure applied while doing the lapping operations, what's the pressure or the load applied on the top half of the lap. That is very important. If you are applying more pressure means more metal will be removed, and if it is less means the operation will be slow but you are getting a good surface. The grain size of the abrasive, that is another factor which decides the surface finish. The grain size, when the grain size becomes small, the surface generated will be very smooth. Then the concentration of the abrasive in the vehicle, that is the total concentration of the abrasive in the oil. If more concentration means more number of abrasive particles, and the machining operation will be somewhat faster. And the lapping speed is also another criteria which decides the performance of the surface as well as the machining speed. Then another two different finishing operations are polishing and buffing. Polishing is a finishing operation to improve the surface finish by means of a polishing wheel made of fabrics or leather and rotating at a high speed. The abrasive grains are glued to the outside periphery of the polishing wheel. So the polishing can be done by manual, by using hand, only by using a leather or fabrics which is impregnated with the grains, abrasive grains. So it is sticking on the surface, this fabric surface or leather surface, and you are rubbing with this on the workpiece. So this is very common. We are using this in our metallurgy lab for polishing the specimen to get the good surface, the structure of the piece when we view in the microscope. Another operation is buffing. Buffing is a similar operation, but it uses it is similar to polishing, in which abrasive grains are not glued to the wheel. So here we are not using glued wheel or glued fabrics or impregnated fabrics are not used, but are contained in a buffing compound. So a compound is used, a separate compound is used that is pressed into the outside surface of the buffing wheel while it rotates. So it is a separate, the abrasive particles are separately used as a compound, and a surface is used, that means a buffing wheel is used for polishing, for buffing operations together with this buffing compound. As in polishing, buffing is usually done manually, although machines have been designated to perform the process automatically. Buffing wheels are made of disc of linen, cotton, broadcloth and canvas. All these are the different buffing tools. So this is also used for very smooth, for getting very smooth surface. So this is one of the schematic sketch of the buffing operations. You can see this is the buffing wheel. On the surface you can see the buffing compound. It is spreading over the cylindrical surface, and this cylindrical tool, this buffing tool, is rotated on the work surfaces. Then honing. It is another important finishing operation, especially it is done for finishing the surface of the internal parts like holes. Honing is a finishing process in which a tool called hone is used. Hone. It carries out a combined rotary and reciprocating motion. So this hone tool is having two types of movements. One is rotation, and together with the rotation it is reciprocating. And while the workpiece does not perform any working motion, so while workpiece is stationary, only the tool or the horn is moving. Most honing is done on internal cylindrical surface. So to clear or to finish the surface, internal surface of a hole or a cavity, we can use this honing tool. The honing stones are held against the workpiece. So honing is normally done by using a honing stone, that is the tool, with controlled light pressure. The honing head is not guided externally but instead floats in the hole, being guided by the work surface. So it is desired that honing stone should not leave the work surface, and the stroke length must cover the entire work surface. To get the good surface finish, the stroke, that means the reciprocating movement of the horn, must cover the entire length of the work surface. So this is the photo of the honing tool. You can see the spindle, which is normally fitted on a machine, and these are the honing stone where the cutting or the machine takes place. So these are the honing tool. This can be replaced. So after a worn out, you can replace only this tool. So there are multiple pieces of this type of tools, and non-abrading bronze guide is this one. So this is the honing tool. The honing tool is given a complex rotational and oscillatory axial motion, which combines to produce a cross-hatched layer pattern of very low surface roughness. So the pattern is also not a, a linear pattern. So because of these two types of movements, you will be getting a cross-hatched. It's a good pattern. Normally preferred for the low surface roughness. So here this explains how the operation is taking place in honing. So this is the honing tool with this abrasives here, that is the stone, honing stone on its surface. This is the workpiece, cylindrical workpiece. We want to finish this internal surface, hole surface. So this is normally rotated. The tool is rotated. This is the spindle. It is connected to a motor. It is rotated. At the same time, it also reciprocates to cover the entire length of the hole or the height of the hole. So here you can see one of the stick, this abrasive stick on the honing tool, and this is the spring. So because of the spring action, because by pressing the spring you can insert inside a hole, then after inserting it will touch the internal surface of the hole, then you can rotate and reciprocate. So this is the pattern normally obtained by in a in a honing operations. So honing stone is also made out of aluminum oxide or silicon carbide bonded abrasives. Here also the cutting parameters are rotation of the rotation speed of rotation of the horn, then its oscillation speed, reciprocation speed, then the length and position of the stroke, then honing stick pressure. So how much pressure the spring exerts on the surface. The parameters that affect material removal rate (MRR) and surface roughness are the pressure exerted by the horn, the peripheral honing speed (VC), then the honing time, how much time you are rubbing over the work surface. All these are affecting the material removal and the surface roughness. Then another important finishing operation is super finishing operation. Super finishing is a micro finishing process which produces a controlled surface condition on parts which is not obtainable by any other methods. So it is controlled surface. The operation, which is also called micro stoning, consists of scrubbing a stone against a surface to produce a fine quality metal finish. The process consists of removing chattered mass and fragmented or smear metal from the surface of dimensionally finished parts. As much as 30 microns to 50 microns of stock can be efficiently removed with some production application. The process becomes most economical if the metal removal is limited to 5 microns. So these are the important super finishing and finishing operations in manufacturing technology. Thank you very much.